So with that, okay, we'll continue with this topic, and now we'll be discussing about interpretation or understanding of two-dimensional data. So, as compared to one-dimensional data, in two-dimensional data, the problem is that we are not looking after only just one axis or only just one parameter of study. We now have two parameters, and the data will have to be stored in something like this. It cannot be stored in an array or a vector anymore. Now we will have to use a matrix or a multi-dimensional array, or exactly to be specific, two-dimensional array to store our value. So this is one just survey data. Uh, this is a survey of like the usability or the user experience of a particular software's user interface GUI. Okay, so this survey was done on a specific set of people. They were given a software and they were asked to give responses towards ease of use of that software, how easy they find the software to use, and enjoyability of the software, how much they enjoy using the software. So although these two parameters seem to be almost the same, but I don't know why they did such a study. So on the one axis we have ease of use, on another axis we have enjoyability for a given software. Now, given this data set, can you draw a histogram for the above data? Obviously not. Why? Because now we do not have a linear data or a single dimensional data. If we want to draw histograms for such a data set, what we'll have to do? We'll have to draw multiple histograms. So there will be a scale. Then we'll have first a histogram for enjoyability's value -2. So this is like very less enjoyable, very high. Data is like very tough. Very easy. Okay, so what we can do for first of all for this E0, I would represent them by X and Y. Okay. So we can have first X. This is not exactly what it may look like, but this is a histogram for X0. Then there will be another such histogram for maybe X1. Another one for maybe X2. But the problem with histograms are they are not just line plots. What are they? They are long bars like this. And now the overlapping areas are not visible. It doesn't make sense to draw histograms for two-dimensional data. Then what we would do? We'll try out other alternatives. So we can go for 3D bar chart. What are 3D bar charts? You put the parameters on the two axes and you plot the values on the third dimension, in the third dimension. So when you will see this particular bar here in this 3D diagram, it denotes that when the enjoyability is very less and the ease of use is very tough, most of this most of the users have voted for this. So it can be interpreted as most of the users who found the software to be very tough also found it very less enjoyable, and so on. So this is what a 3D bar chart is. But the problem with 3D bar chart is they are not very good with printing, and you will require to view them from different angles in a computer graphics intensive program. Okay, you cannot see the values on the back side of that. Another option is to draw line plots. So just like histograms, now in the line plots, what we will do, we won't fill up the areas covered by these graphs, and rather the lines would be drawn in different colors and different shapes. And we'll use then put up legends to identify which line denotes which data element in our data set. But the problem with these types of representations are that they again interpret the different columns or different data parameters as independent of each other. They again study them independently. So now what if we want to understand the relationship between those parameters? So here is an example. Let's say you collected the data of age and height in any particular school, and then you plotted it. So for any particular sample, let's say there is this one sample for student one whose age is 11 years old and whose height is maybe 158, maybe something. So for that, what we would do, we would go ahead on somewhere over here 11, and then at 158, I put up a point like that. So that way, we plotted the points for all the data samples in our data set. And after plotting all those points, what we realized that for a particular group of people within our data set, the values lie on the lesser side of the x-axis or the age. Or maybe we can say that this particular data set is slightly skewed towards the left. We will get into how to interpret these type of graphs a bit more in a bit more detailed way in a few minutes. But as of now, what we can try to infer is that there is certain division between the type of people within this data set. Some of them are on the lesser side of our scale, whereas some of them are on the higher side of the scale. However, that is very obvious to be seen, and that can also be identified from these charts. However, what we get to learn even better from this chart is that if we can draw a line like this, if you will see that most of the population is scattered somewhere around this line only, most of the population. So what this denotes is that there is some relation between height of the students and age. So that with increasing age, the height also increases. Is that true? So now this is very obvious that with age, height will increase. Sir. What is there to analyze on this? But let's say if these two parameters are certainly more complicated parameters. For example, let's say you are trying to study two parameters. Let's say on one scale you have pizza prices in canteen. Okay. And on another scale you have weight of students. And let's say if the curve gets drawn like this, so what would this represent there? Sorry, did I? So what this particular phenomenon tells us that when the pizza prices are less, the weight of the students increases. Whereas when the pizza prices are high, the weight of students is found to be lower. In most of the cases, obviously there will be outliers, but in most of the cases, we can see such a trend. So when these parameters are fairly complex, these kind of scatter plots can give us insights into the relationship between those parameters. Alright? And in statistical terms, such relationships are called correlation.